Eutrophication. Eutrophication is a currently observing process in which an ecosystem becomes enriched with an increased supply of nutrients, such as phosphorus and nitrogen. Eutrophication is often associated with a number of aquatic environments such as lakes, estuaries, rivers, and other impoundments. And as a consequence, a number of ecological changes may arise. The most common example is the increased production of algae, turbidity, heterotrophic bacteria, and sedimentation, which in turn will often lead to a decrease in species diversity, benthic faunas, oxygen, and sunlight. Eutrophication is a common ecological problem which is driven by anthropogenic factors. In 1970, Lake Constant was under eutrophic stress, through which genetic alterations in a specific species of water flea were implemented. The dramatic change in the ecological state of Lake Constant was due to the input of phosphate detergents and fertilizer runoffs. For all these reasons, the ecological health of Lake Constant today is in high risk of hypoxia and algal bloom. Not many of you are aware of the eutrophic state of peel-Harvey estuary, but let me tell you a little bit about it. Peel-Harvey is recognized as the most at-risk estuary in Western Australia. It consists of two shallow adjoining basins which is home to many warbirds. Due to the proliferation of macroalgae and toxic algal growth, suggestions that the eutrophic state of peel-Harvey will only continue to shift. The most common evidence of eutrophication occurs in the Peel region of the adjoining basin, where excessive amount of inorganic nutrients and Cladophora has increased. In 1987 and 2003, a study was conducted to observe the state of peel-Harvey. Evidence indicate the biodiversity and the density of benthic faunas such as mollusks and crustaceans have decreased since 1987. It is suggested that anthropogenic impacts manifested by phosphatic fertilizers and the discharge of sewage from rural industries have caused peel-Harvey to shift. In 1960 and 1994, eutrophication was responsible for the public complaints and depression of real estate values. Extreme levels of Cladophora and nodularia significantly overlaid the bottom of the estuary, which resulted in the accumulation of hydrogen and sulfide, causing coastal shoreline to deteriorate. In response to these issues, an attempt was made to improve the quality of peel-Harvey by installing a 2.5 artificial channel to increase tidal exchange of peel-Harvey in the Indian Ocean. This led to a decline in macroalgal growth, but unfortunately no evidence of improvement was seen. It is important to understand that eutrophication entails a significant amount of attention from natural and environmental scientists. And without substantial alterations in the management of peel-Harvey, there is a threat that estuarine health will further decay. In 2008, the Water Quality Improvement Plan proposed several methods to effectively reduce eutrophication in the peel. These include the use of a low water soluble fertilizer to reduce phosphorus runoff, direct application of fertilizers, which is suggested to reduce phosphorus discharge by 13%, the use of soil additives such as red sand to absorb phosphorus more effectively, and the use of urban agricultural drainage systems to remove excessive nutrients. NASA in 2011, a program was funded by Caring for Our Country to improve the quality of the peel-Harvey. The program aims to install 46 stormwater retrofits, 2 phosphorus retention trails, 2 biofilters, and revegetation of riparian areas of the estuary. To further understand how to restore estuaries and other impoundments, research programs attempting a widespread of ecological technique is advantageous. The European Union have managed to improve the quality of estuaries using collaborative research. If effective management is introduced in the peel-Harvey, it is also can guide mitigation initiative to restore peel-Harvey and other environments under eutrophic stress. With current and future management of peel-Harvey, it enables the practice of scientific applications to respond to ecological problems such as eutrophication. This is important to understand the process of eutrophication and to find out what we do not already know to help guide future research.